Hey everyone, we're going to find the Taylor series for f of x equals square root of x centered at the given value of a equals 16. So we're going to find a sum for this, and then we're also going to find the radius of convergence. So to write it out in this format, we're going to start with n equals 0. This would be our first term. And we're going to do f of 16 equals the square root of x evaluated at x equals 16. And this equals 4. All right, next, for the first derivative, or this second term here, that would be f prime of 16. That equals 1/2 x to the power of negative 1/2. Evaluating that at x equals 16, that gives me 1/2 times 1 divided by 4. All right, for 2, we have f double prime of 16. That would be this piece here. That's going to equal negative 1/4 x to the power of negative 3/2 at x equals 16. That gives me negative 1/4 times 1 divided by 4 cubed. All right, at 3, if f third derivative at 16 equals 3/8 x to the power of negative 5/2. When you evaluate that at x equals 16, that gives me 3/8 times 1 divided by 4 to the 5th. So I want to put this one as to the first power. All right, let's do one more. So if we do one more, we're going to get 4. The fourth derivative at 16 equals negative 15 divided by 16 x to the power of negative 7/2. And evaluating that at x equals 16 gives us negative 15 divided by 16. And this is going to be times 1 divided by 4 to the power of 7. All right, now that we have this, we can write this in this format here, which would be the sum as n equals 0 to infinity, and we're going to have our nth derivative at 16 divided by n factorial times x minus 16 to the nth power. All right, using all of this, we're going to expand it, our Taylor series, and we're going to generate that. So let's write this all out. It's going to take some motion here, so it's going to take some space. So this is going to equal 4 divided by 0 factorial times x minus 16 to the power of 0 plus 1/2 times 1/4 times 1 divided by 1 factorial. You can skip that step if you want. And then we have x minus 16 to the power of 1. Then we have minus 1/4 times 1/4 cubed times 1 divided by 2 factorial times x minus 16 squared. Then we have a plus 3/8 times 1 divided by 4/5 times 1 divided by 3 factorial x minus 16 cubed. Then we have minus 15 divided by 16 times 1 divided by 4 to the 7th power times 1 divided by 4 factorial times x minus 16 to the 4th power. And then we could go on and on and on. You can see a pattern here. So the pattern is, if I factor out the 4 plus 1/8 of x minus 16, if you factor out an 8 here, you're going to get this equals the sum. And this is skipping the first two terms. So I'm factoring out this part. So I'm going to start at n equal 2 which will be starting here. And that's going to give me negative 1 to the power of n minus 1. And then we're going to have 1 times 3 times 5 times dot 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 times 2n minus 3 divided by 2 to the power of n times 4 to the power of 2n minus 1 times n factorial. And this is times x minus 16 to the nth power. All right, so basically, again, I just factored out these first two terms. Well, I didn't factor them out. I just pulled them out here, and then I wrote my sum this way. This goes to infinity. Now, simplifying this, and I'm going to look at this part right here. This can be written as 2 to the nth times 2 times 2, 2 squared. So 2 times 2n minus 1. So when I do that, I'm going to simplify this as, let's duplicate this. All right, so that's going to simplify to 4 plus 1/8 times x minus 16 plus the sum. And now we're starting at n equals 2 to infinity. And we have negative 1 to the power of n minus 1. And it's 1 times 5 times 1 times 3 times 5 times dot 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 times 2n minus 3. This is going to be times x minus 16 to the power of n. And then simplifying that, we're going to have, we had 2n times 2 times 2 to the power of 2n minus 1. So when you have that, that's going to factor to 2, because you can just add all this up. This is going to be 5n minus 2. All right, and then we're going to get times n factorial. All right, hope I got everything. All right, now, once we have that, we're going to use the ratio test to simplify this. So for the ratio test, what we're doing is we're taking the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So basically what you're going to get, this equals, is the limit as n approaches infinity. And I'm going to write it down here because we're running out of room. So basically that's what I'm going to do. And let's write it all out because this is long. So we're going to get absolute value. Now what you do is you're going to take this and you're going to put the this part right here, and you're going to put the n plus 1. Doing the absolute value of a sub n plus 1 divided by a sub n. All right, so when you do that, you're going to get absolute value of negative 1 to the n power, because we're adding the 1 to that. Then we're going to have 1 times 3 times 5 times dot 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 times 2n minus 1. And then putting this in the numerator, this is going to be x minus 16 to the power of n plus 1. 16. All right. Trying to go too fast. Okay, and the denominator is just going to be 2 to the power of 5n plus 3, because you're just adding 5 to this. And then you're going to get n plus 1 to factorial. Now, what I'm going to do is I have to divide by a sub n, and that's the same as multiplying by the reciprocal. So I'm going to put it here, down here, because there's no room on this to write it. That's going to be, when you flip this over, you're going to get 2 to the, whoops, what happened? 2 to the power of 5n minus 2 times n factorial divided by negative 1 to the n minus 1 power times 1 times 3 times 5 times dot 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 times 2n minus 3 and then we had x minus 16 to the nth power. And what we're going to do is simplify all this. And what's going to happen with the ones is they're going to, oh, this is absolute value. They're going to, cancel out. So, and absolute value of -1 is 1. So what we're going to end up getting is absolute value of, let's see. Let's just simplify. We're going to get the limit as n approaches infinity of 2n minus 1 times absolute value of x minus 16 divided by 2 to the 5th power times n plus 1. And this is going to be the absolute value of x minus 16 divided by 32. All right. Now that once you get that, times, this had n plus 1. So this is just going to cancel that out. And then you're going to get the limit as n approaches infinity. And this is going to be 2 minus 1 divided by n divided by 1 plus 1 divided by n, which is going to equal absolute value of x minus 16 divided by 32. And then the limit of this is just 1. So that's going to be times 2. So this is going to equal absolute value of x minus 16 divided by 16. And we set that less than 1. So when you cross multiply, you get absolute value of x minus 16 is less than 16. Therefore, our radius of convergence is 16. And that's it. Thank you. Have a nice day. Bye-bye.